Hi there. This video series is to display my problem-solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I'm showing my approach to solving the 26th Project Euler problem from start to finish, vocalizing my thought process throughout. As always, I will link to Project Euler and my repository in the description. Let's dive in. Problem 26, Reciprocal Cycles. A unit fraction contains 1 in the numerator. The decimal representation of the unit fractions with denominators 2 to 10 are given. And there's that list, where 0.1 parentheses 6 means 0.16666 repeating and has a 1-digit recurring cycle. It can be seen that 1 over 7 has a 6-digit recurring cycle. Find the value of d less than 1,000 for which 1 over d contains the longest recurring cycle in its decimal fraction part. Okay, so for this one, I actually don't immediately have an idea of where to begin. I have a feeling that we might need to do something with regex, perhaps. Not 100% certain. But here's what we're gonna do, is we are going to start by Googling Python find recurring pattern. So this person is like, I want to be able to find the pattern that repeats itself. Okay, so okay, so this is saying this regex, let's look at this demo. Okay, so I think what this is doing, let's see, first capturing group is this, matches any character except for the line terminators, matches the previous token between 1 and unlimited times as few times as possible, expanding as needed, matches the same text as most recently matched by the first capturing group, matches the previous token between 1 and unlimited times as many times as possible, giving back as needed. Okay. And let's see the other demo. This one does not match the first thing, And I think what we need is actually just this part. So we don't care about the beginning of it, but we do care about the ending. Because, like, this is not a repeated pattern after a decimal. So, let's see. Go ahead and do our make a new file. Copy these 2 lines. Copy this. Oop. And then finally copy this. Okay. So, we have our pattern, our limit, I'm going to set equal to 10 right this second. And the reason I'm setting it equal to 10 is because we know that 7 is going to be the correct answer for 10. We don't know the correct answer for 1,000. But if we can make our program return the correct answer for 10, then we have high confidence that it'll return the correct answer for 1,000. So, longest recurring cycle and its decimal fraction part. So I think we want for, let's say, n in range, start with 2, go to limit plus 1, so that we get everything in the limit. And then we're going to do, let's see, call this, I'm just going to call it to check, which isn't a great name, but, let's see, so we want string representation of 1 divided by n. And then max length equals, I'm going to say 1. Although, yeah, we'll just leave it as 1. And let's see, so we want to print and let's make this a formatted string. Let's see, recurring cycle of there. Actually, we're just gonna make this say that. And what we need to do is check this string against this pattern. Which I don't actually know how to do in Python, so I'm not sure what this U is. This might not be Python code. but let's just give it a shot. Right? Okay. So, I'm not entirely certain how this works, so we're just going to try it out a little bit. Gotta type Python to run with the Python program. Okay. So, we got the correct answers of no recurring cycle. And then oh, this is supposed to be max in. So we found a bug. And this is going to be found equals, and I'm just gonna if length of found, which I keep mistyping, is greater than 0, then the cycle is going to be found at index 0, and length is going to be cycle if length is greater than max length equals length, just like we normally do, and then max n equals n. So, obviously we can probably cut out some of this, and actually let's go ahead and like one-line this. So we just really need the length of found at 0. And sometimes... okay. Well, in order to store the length, we have to have it as a variable, so... I know that normally I'm, like, not wanting to do too much all in one line, but I think that this is fair. I think that this is pretty readable still. And let's go ahead and see if we get the correct answer. And we do. So 1 out of 7 has a recurring cycle of 6 digits. So let's go ahead and bump that limit up to 1000 and see what we get. And obviously that took like 1/100 of a second to run. And we get the answer of 405. Says it has a recurring cycle of 9 digits. Let's go ahead and plug that into Project Euler and see if that is the correct answer. Okay, well, I might have to relog in. Maybe not. Nope, that is not correct. Okay. Recurring cycle of 9 digits. So that's not right. I wonder... So here's what I think is most likely happening. I think what is most likely happening is this is rounding somewhere. I am going to go ahead and see. Let's see. Let's go ahead and try it without this part. So without that last thing and see if that gives us a different answer. First, let's see if it gives us a different answer for 10, which it should not. Okay. And then let's see if it gives us a different answer for 1000. Yeah, so that's actually probably worse because that says recurring cycle of 8 digits. So I'm going to guess that 73 is definitely wrong. Let's go ahead and plug that in just in case, but I don't think it's correct. Yeah, as I suspected, especially since like the more reliable algorithm had this 405. Okay. I'm gonna go ahead and do... No. Okay, so what I'm trying to think is what is a way that I can most easily see this data without, like... And I think this is it. So I'm going to bring back my cycle variable specifically so that I can print it out. So obviously it's not going to print out for everything, but we're going to have a pretty lengthy output here. Okay, so tons of these found cycle 0. Oh, let me put this back on there. There we go. That looks better. Okay, and then now we're back to having that 1 over 405. Okay, 36... And actually, I'm going to go ahead and move this. Because I'm going to guess that I will be able to see something just visually that I can't see here. So let's run through this again. Okay. And obviously I don't want to just find the answer visually, but I want to see if I can see, like, this recurring pattern, maybe. Let's look at 405 in particular, which we know is the wrong answer. And obviously I could just brute force this, right? This actually looks to like it has a one digit recurring. So yeah, obviously we are getting a rounded answer here, which is not what we actually would prefer. verb, but it has to end somewhere, and it makes most sense to round. The question is, how do we make our program account for that? Okay, so here we have this pattern, and we can see it only repeats twice, which makes sense because it's so long. Okay, so let's do some research on Python division. So we don't want to do floor division, obviously. Python division specify length. Okay. That is not the correct answer, actually. Right, because in Python, floats aren't necessarily accurate. That's probably why it's not. So this doesn't look super helpful. Okay, so what we want is to specify the precision if we can. So I think we need to do this import decimal. So I think we want to do some sort of like... Ooh. I think we need to use this decimal thing. So we can say to round up. By default, the round function rounds down. That might be what we want. So I think we want to import decimal. And just sort of see. So import decimal. Okay, so let's see if that gives us a different answer. It should otherwise be identical. Okay, so now we found a recurring cycle of 15 digits. I'm just gonna go check whether 2279 is the correct answer real quick, because we might be done. It is not. Okay, so I kind of thought probably, because this again is still giving us some arbitrary rounding, right? Let's look at 279. Okay. So we want to round this answer, and I want to round it to a precision of 100. Let's see again. Does this give us a different answer? So previous answer is 1 over 279 and 15 digits. This one is invalid operation. Let's try throwing parentheses around this just to see if that works. Okay, so I'm not sure where they get this round method, honestly. So let's do another Google Python decimal. Specify precision for division. Use the built-in round function. Okay, so that works for floats, though, I guess. Let's try it without the decimal real quick. Just to see whether that works. And again, we're looking to see... Okay, we're back to 405, which is obviously incorrect. So we definitely need the precision of the decimals. Okay. yoink this, because I prefer this type of import statement. And then apparently we can just set the precision here. So let's do that. Alright, so we'll see if that gives us... Oops, we don't want this. Okay, so now we found a recurring cycle of 51 digits, which seems much more likely to be accurate. So 613, are you the correct answer? No. Let's go ahead and up that precision once more. Okay, so obviously we're printing a lot more output now, which is going to slow us down pretty significantly. Oh, goodness. I'm going to go ahead and delete this print statement. Actually, yeah, I'll just delete it. I don't think we need it. I'm going to up this to 1 million. And I'm going to run it again. Obviously, it's taking much longer to run now. Because it has to hold all of those digits in memory. Let's see if it still takes under a minute. And I'm guessing we are still going to get the incorrect answer as long as we have this. So let's check if 499 is the correct answer. I'm going to guess it is not. I was right. And now it's checking, like, hey, are you a robot? Because I appear to just be checking various answers. That's valid. Okay, so I guess it doesn't matter whether this will work or not, as long as it doesn't run in time. So let's go ahead and stop that. And bump this down to... That's 10,000. Try it again. Okay, so 97 has a recurring cycle of 96 digits. But previously we found one that at least said that there was a recurring cycle of 498 digits, so that feels incorrect, right? Let's look at 499. Actually. So I'm not sure why this is getting an incorrect answer, because 97 can't possibly be correct. There's no way. We can go look at 97, maybe. No, I'm not scrolling all the way up there. Let's just say precision 1000. Tell me what it says. It's still saying 96. What was our precision for this? I think our precision may have been 1000 for that. So let's try a precision of 100,000 and see what that gives us. because it's not going to be 97. Okay, so why is it still saying 96 digits when we know there's a recurring pattern of 498 digits for, what was that? 499. And print. I am going to guess that 499 gets more than one match. Let's see. Yup. Okay. So instead of having this cycle be like this, let's see, are there other options here? I think find all is probably still our best bet, and we're just going to have to do a if the length of found is greater than 0, then for cycle in found. And that'll make us run a little bit longer, but I think it is going to give us a more correct answer. So let's let this one run, even though it's going to end up taking a little bit too long. Okay, so we found 1 over 983 has a recurring cycle of 982 digits. Let's delete our little print statement here. And check how long this took to run. Finish races. So it started at 2026. Ended at 2036. So 10 seconds, which isn't too bad. And now I am much more confident that this is the correct answer. I don't think that pushing it up to 1,000,000 is going to give us a better answer, but let's see if we can do 200,000. If that still runs in under a minute, it may not. We're just gonna have to kind of wait and see. But let's see if this 983 is the correct answer meanwhile. And it is! And apparently only 89,756 other people have solved that. Okay, so yeah, this was going to give me a much higher confidence, but it did take twice as long to run, which makes sense because we made the numbers twice as long. Okay, So, we're still only at a difficulty rating of 5%, by the way. But we got that one correct. So yeah, let's do a little bit of the overview of what we had done here. So we did our normal beginning and ending with a timestamp, so we know precisely how long our program took to run. We set our precision just arbitrarily high so that we wouldn't have weird rounding problems. We made a regular expression that would match a group of some characters appearing 2 or more times. Would have been slightly more reliable, I feel like, to have it be able to match at the end, but because of how we have to deal with the rounding and this arbitrary precision cutoff, there's just not really a way to do that reliably without knowing the answer ahead of time. Like this 982 digits, like, okay, I could make this number some number above 982, but I'd have to know the result of this. But it's really cool that the answer is 983 and it has a recurring cycle of 982 digits. So, do, and then we set our limit to 1000 because that's what the problem required. We set a max length of 1 and a max n of 1. We looked at n from everything from 2 through our limit inclusive by adding this one here. We found our string value to check with our regex pattern by doing a decimal division so that we would have this precision that we wanted, and then converting it to a string. Then we ran the regular expression against our regular expression against our string, and then finally if there was anything in string, which actually we don't even need this anymore. There we go. Because it won't have any cycle and found if there's no items in found. So let's see, for every cycle that we do find, we check the length of the cycle, and if that length is greater than the max length, then we save that, and we save the n. So if you run through this again, it'll probably still take 20 seconds to run, thereabouts, but it should give us the exact same answer without any issues, and obviously if there would be any issues, we would have run into them by now, just making their code a little bit better by doing that refactoring. So, alright, I think yep, there it is. It took 21 seconds again, but it's the correct answer. So I think we're good for today, and I will see you in the next one.